What's happening? Let's talk about meiosis and genetics, because it's fun. Oh, you close the door? So we're going to talk about meiosis and genetics, Mendelian genetics to be more precise. Looking at Punnett squares and all that fun stuff. So, anyway, meiosis, remember, it's very similar as far as the steps are concerned to mitosis. You start with a diploid cell. So again, I guess let's review that. So diploid cell means a cell like a body cell, your somatic cells that have full sets of chromosomes. One set from mom, one set from dad. Your body cell has the full set. A haploid cell would be like a gamete, so like a sex cell that only has half of the chromosomes, so that it can create offspring. Okay, and they don't have an overload of information. They would have, they would have the correct amount of information. So if an organism's diploid number is 60, what's their haploid number going to be? It's going to be 30. Yeah. So. And backwards too. If the haploid number is 20, the diploid number is going to be 40. Okay, so meiosis, the process itself, starts with a diploid cell, and the idea is that it's reduction by division. You're reducing the number of cells by dividing the cell out. So you get. I told you you're going to have to be quiet. You can't do that right now. At the end, you can do some things, but not right now. Okay. I mean, if you can't listen, then get out of here. My day never stops. Tell you guys the same thing in class and get home and have to tell him the same stuff. Anyway. So, we're reducing the number of chromosomes by dividing the cell out. And so the end result of meiosis, you get 4 genetically different haploid cells. So 4 genetically different haploid cells is what you get. And again, what type of cells are they? Remember, there are gametes. Okay, so there you go. A lot of the questions, like I said in class today, deal with the idea that meiosis creates variation within a species. A lot more variation is created through the process of meiosis and through sexual reproduction than asexual reproduction, where you would only have one parent involved. Okay, so for instance, the sorting and recombining of genes during meiosis and fertilization usually leads to the production of would it be embryos with traits identical to those of all the members of the species? No. Offspring with some traits that did not appear in their parents. Yeah, again, you might not look like your parents, but that's because of the idea of crossing over and recombining those genes during crossing over. Okay. Diagram. So there's a diagram here. Okay. Diagram below shows a process that can affect chromosomes during meiosis. This process explains what?
Is that the test?
Yeah, it's a test. Are you going to be quiet or what?
I'm going to be quiet. I'll be quiet. I just kind of...
Yeah, this process explains why some offspring are genetically identical to their parents. No. Why some offspring physically resemble their parents. Why it explains the origin of new combinations of traits in offspring. Yeah, the origin. So in other words, the origination, where these new traits kind of suddenly appeared in the offspring. That's a good deal. Which process produces gametes? Meiosis. Meiosis is critical to sexual reproduction because it allows a species to retain certain characteristics. Meiosis prevents a species from, would it be developing new advantageous characteristics? Well, it's not going to stop evolution. Crossing geographical barriers, that's like rivers and stuff. Meiosis doesn't have anything to do with that. mating with other species to produce fertile hybrids. And again, that's another one we talked about. Or losing genetic information that distinguishes it from related species. Now, you keep the same genetic information. You don't keep it identical, but you keep the same genetic information that that is within the species at least. Okay, so which of the following does meiosis play a more significant role than mitosis? Would it be through reproducing asexually or increasing genetic variation? Well, it's obviously going to be increasing genetic variation. Greatest amount of genetic variation is produced in offspring that reproduce what? Sexually or asexually?
I'm back.
It's going to be sexually. Okay. So here, I guess we'll get into the dihybrid, or not just the dihybrids, but the Punnett squares. So here's the one I was talking about. That is, it's already done for you, and you just have to interpret the results. Okay. So shouldn't be too tough. Another one. A mother wants to know whether her unborn son might contract a recessive trait that she carries. Which of the following circumstances would result in her son showing the recessive trait? Well, it's a recessive trait that she carries, so she's gonna get the recessive trait from the mom, right? So what would lead to her, the offspring getting it? The dad giving a recessive trait, okay? Right? The dad giving a recessive trait. In certain species of mouse, gray fur is dominant over cream-colored fur. If a homozygous gray mouse is crossed with a cream-colored mouse, the genotype of the F1 generation will most likely be what? Okay. Again, that's just going to be homozygous, big G, crossed with little g, and then you're just looking for the very first generation. So that shouldn't be too hard. So a lot of these are just single, mono hybrid crosses where it's just 4 squares. Okay.
I want to do a water bottle.
No, stop.
When it's done.
You know that drives me berserk.
When it's done.
That's what I say in class. Here's another one. Dihybrid is already done for you. This is a cool question, and I'll be interested to see how you guys do on it. It gives you, like it shows it set up, okay, and then you have to determine what the parents were. So you have to kind of go backwards. So really, again, some of y'all can just look at it and see, but if you just use the 1 to 3, 1 to 4, 2 to 3, 2 to 4, and use that rule, you'll be fine. So like this first square here would be, well, that's 1 to 3. So you could just write those out as far as the parents are concerned. Okay. But anyway, that's a cool question.
What are y'all learning about?
Ask Colt. He came to school with me.
Really?
He probably knows. Yeah, he did that last week.
Who remembers me when I hit my head on the concrete?
That was last year. You think I have the same students?
Oh yeah! Sorry guys.
Whew. Sex-linked traits. I'm trying to see if there's even one that you have to do that's a dihybrid. Yeah. There is one dihybrid that you actually have to do. So anyway, that's really about it. Let me show you real quick on the whiteboard.
Wait.
Give me the whiteboard. Hurry up. This video is already running way too long.
Really?
Yeah.
How long?
Way too long.
Do y'all guys ever bottle flip and landed?
Oh no, they never have. They've never.
Have y'all done a capper where it goes like?
Oh no, they don't even know what that is. That's only at your school. It's only popular in your school.
Or where it goes like that.
Yeah. Move that out of the way. All right, so let's say
RJ.
Yeah, that says RJ. Alright, so let's say that's your parents, okay? And I know it might be backwards, I don't know how this is. So remember, if you want to set up a dihybrid, 1 to 3, 1 to 4, 2 to 3, 2 to 4. So you number your alleles.
Or you can go 1, 2.
Just stop. You don't even know what we're talking about. Okay? So 1 to 3 would be big R, big Y. Okay?
Right.
1 to 4 would be big R, little y. 2 to 3, little r, big Y. And then 2 to 4, little r, little y. So that's just a quick review on setting up the dihybrids when it's a 16 square. Really, I think there's only one that you have to do it for. So as long as you can do that, you should be good to go.
Can I do a bottle flip for them?
Oh, I don't think we can end the video without that happening. So here it is. Your one chance. Oh, that was a terrible failure. See y'all tomorrow. Enjoy.
Bye.
Peace out.